Hello, everyone, and welcome to today's podcast. Have you ever wished you could jump into a time machine and travel hundreds of years into the future? Or maybe go back and witness historical events firsthand? Time travel has fascinated people for centuries and has been a major topic in books, movies, and television. But what does science actually say? Is time travel possible, or is it simply science fiction? Today I'll be exploring the question, is time travel possible? Based on current scientific evidence, my argument is that traveling forward through time is possible and has already been proven through time dilation, while traveling backward through time remains theoretical and unsupported by modern physics. To understand this topic, we first need to understand what scientists mean by time travel. When most people hear the phrase time travel, they imagine stepping into a time machine and instantly moving to an anchor point in history. However, physics describes time travel differently. According to Einstein's theory of relativity, time itself is flexible. It can move at different rates depending on speed and gravity. This means that under certain conditions, one person can experience less time passing than another person. One of the most important concepts related to time travel is time dilation. Time dilation occurs when an object moves at extremely high speeds, especially speeds close to the speed of light. According to Einstein's special theory of relativity, the faster an object moves, the slower time passes for that object compared to someone who is standing still. A famous example of this idea is known as the twin paradox. Imagine two identical twins. One twin remains on Earth, while the other travels through space in a spaceship moving near the speed of light. After several years, the traveling twin returns home. Surprisingly, the traveling twin has aged less than the twin who has stayed on Earth. At first, this seems impossible. How can two people experience time differently? However, physicists have shown that this effect is real. According to Sphinx-Gar's research on time dilation and special relativity, the paradox is resolved because the traveling twin changes frames of reference during the journey, while the earthbound twin does not. As a result, the traveling twin experiences less time. Although this example sounds extreme, scientists have observed time dilation in real life. Atomic clocks placed on airplanes and satellites have shown measurable differences compared to clocks on Earth. These differences are small, but they prove that time dilation is real. GPS satellites provide one of the best everyday examples. GPS systems rely on incredibly precise timing to determine locations. Because satellites move at high speeds and experience weaker gravity than people on Earth, their clocks run at different rates. Engineers must constantly correct for these differences. If they didn't, GPS systems would quickly become inaccurate. This means that time dilation is not just a theory. It's something that scientists and engineers account for every single day. Another way time travel into the future can occur is through gravity. Einstein's theory of general relativity explains that gravity can bend space and time. The stronger the gravitational field, the slower time passes. This effect is known as gravitational time dilation. Research by Masumi Kasai explains how gravity affects time and how clocks near massive objects run more slowly than clocks farther away. Near extremely massive objects such as black holes, this effect becomes enormous. Imagine a person orbiting close to a black hole while another person remains far away from it. The person near the black hole would experience time much more slowly. When they eventually returned, many years or even centuries could have passed for the person who stayed farther away. While humanity currently lacks the technology to safely approach black holes, the physics behind this effect is supported by Einstein's theory and experimental observations. Further evidence comes from astronaut studies. According to an article by Elisa Harvey and Vicky Stein, astronaut Scott Kelly spent nearly a year aboard the International Space Station. Because he was traveling at high speeds and experiencing slightly different gravitational conditions, he aged a tiny bit less than his twin brother on Earth. The difference wasn't incredibly small, but it demonstrates the same principle. In a sense, Scott Kelly traveled slightly into Earth's future. At this point, the evidence strongly suggests that forward time travel is possible. In fact, it has already happened. The only limitation is that the effects are usually very small unless someone reaches extremely high speeds or encounters extremely strong gravitational fields. However, what about traveling backward in time? Many theories have been proposed to allow travel in the past. One popular idea involves wormholes. A wormhole is a hypothetical tunnel connecting two distant points in space-time. If wormholes exist and they could be somehow stabilized, some scientists believe that they might allow movement between different points in time. Another idea involves rotating black holes, cosmic strings, or warped regions of space-time. These concepts appear in advanced physics equations and have inspired countless science fiction stories. The problem is that none of these ideas have been observed in real life or experimentally confirmed by anyone. So, current scientific evidence still supports that time dilation informed forward time travel, but no evidence demonstrates that backward time travel is possible. In addition, traveling into the past creates logical problems known as paradoxes. The most famous example is the grandfather paradox. Imagine traveling back in time and preventing your grandparents from meeting. If they never met, your parents would never be born, meaning you would never exist. But if you never existed, who traveled back in time to prevent the meeting? These contradictions create serious challenges for backward time travel theories. Some physicists have suggested possible solutions, including alternate timelines or parallel universes. However, these ideas remain speculative and have not been experimentally verified yet. As I researched this topic, I also found sources that challenge our understanding of time itself. TV and Dre's paper raises questions about whether time is truly a separate dimension or simply a way of measuring events. While these ideas are not widely accepted, they show that scientists continue to debate the deeper nature of time. Modern research is also exploring how time behaves at the quantum level. In a study published by Nature Communications, Alexander Smith and Mehad Amandi investigated how quantum clocks experience time dilation. Their work suggests that quantum mechanics may slightly modify our understanding of how time works in certain situations. This is important because it shows that scientists are still learning about time. Even though relativity has been tested many times, there may still be discoveries waiting to be made. So where does all this info leave us? Based on current scientific evidence, the answer to our question is both yes and no. It's very up in the air. If we define time travel as moving forward into the future faster than other people, then the answer is clearly yes. Time dilation has been confirmed through experiments, satellite technology, astronaut observations, and decades of scientific research. However, if we define time travel as traveling backward into the past, the answer still remains uncertain. While fascinating theories exist, not a single one has been proven. And many of them create difficult paradoxes that sort of challenge our understanding of causality and just logic itself. They're just confusing, to say the least. In conclusion, time travel is not entirely science fiction. Einstein's theories have shown that time is both flexible and can pass at different rates depending on speed and gravity. Scientists have measured these effects and continue to study them today. While we may never build a movie-style time machine, physics has already demonstrated that traveling into the future is for sure possible. Thank you for listening to this podcast. The question of time travel continues to inspire scientists, philosophers, and everyone who wants to know whether a science fiction type time travel machine could be possible, see awesome historic events, or meet your parents when they were kids. There's a ton of cool things you could do with time travel if you could travel backward in the past, but so far we've only found stuff that says you can go forward. As our understanding of relativity and quantum physics grows, who knows what future discoveries may reveal about the nature of time itself.